On July 1st, 2025, telescopes in Chile detected something that shouldn't exist. A comet moving at 58 kilometers per second, faster than anything we've ever seen. And it's producing metals in space the exact same way we refine nickel in factories here on Earth. That's not supposed to happen. This object is called 3I Atlas, and it's only the third confirmed visitor from beyond our solar system. But here's what nobody's talking about. This thing might be older than our sun, possibly 14 billion years old. It's been wandering the galaxy since before Earth even existed. And right now, as I'm recording this, it's passing through our neighborhood, carrying secrets from when the universe was basically a teenager. The question everyone wants answered is simple. Are we in danger? But the real story here goes way deeper than that. Because 3I Atlas is doing things that break our understanding of how comets work. And I'm going to show you exactly why this cosmic visitor has scientists completely baffled. Let me start with what makes 3I Atlas so weird. And I mean genuinely strange, in ways that challenge everything we thought we knew about objects in space. First, the speed. This comet is traveling at 58 kilometers per second relative to our sun. That's about 130,000 miles per hour. To put that in perspective, that's faster than any natural object from our solar system has ever moved. The reason it's going this fast is because it's not from here. It came from somewhere else in the galaxy, and it's been picking up speed over billions of years by slingshotting around stars and massive clouds of gas. When astronomers first spotted it, they immediately knew something was off. The trajectory was hyperbolic. That's the math term for this thing is just passing through and it's never coming back. Most comets we see have elliptical orbits, meaning they loop around the sun over and over. But 3I Atlas? It's on a one-way trip. It came from interstellar space, it's whipping past our sun, and then it's gone forever. But speed and trajectory aren't even the weirdest parts. Let me tell you about the metals. When scientists pointed their spectrographs at 3I Atlas, they detected something that made them do a double take. The comet was producing nickel gas. Just nickel, no iron. And this is where it gets really strange, because nickel and iron almost always appear together in space. They're buddy elements. You find one, you find the other. Except here, 3I Atlas was pumping out about 4 grams of nickel per second with basically zero iron for an extended period. Then, as it got closer to the sun, iron finally showed up. The nickel-to-iron ratio started shifting. This sequential appearance of metals has never been observed in any comet before. Not in our solar system, not in the previous interstellar visitors. Never. Here's why this matters. The process that explains this behavior involves something called metal carbonyls, specifically nickel tetracarbonyl and iron pentacarbonyl. These are molecules where metal atoms bond with carbon monoxide. And here's the kicker. This exact process is how we refine nickel in industrial factories on Earth. It's called the Mond process. We heat up nickel ore with carbon monoxide, create nickel tetracarbonyl gas, and then extract pure nickel from it. 3I Atlas is doing this naturally, in space, on its own. Scientists think what's happening is that the comet's nucleus contains metal sulfides or even bits of pure metal mixed with carbon monoxide ice. As the comet gets closer to the sun and warms up, the carbon monoxide reacts with these metals and creates these volatile carbonyl compounds. Nickel tetracarbonyl sublimates at a lower temperature than iron pentacarbonyl, so the nickel appears first. Then, as temperatures rise even more, the iron starts coming out too. This is exotic chemistry that nobody expected to find on a comet. It suggests the composition of 3I Atlas is radically different from anything in our solar system. But wait, there's more strangeness. Part 1. The Ancient Origin. Let me tell you about where this thing came from, because the origin story of 3I Atlas might be the most mind-blowing part of all this. Astronomers traced its path backward through the galaxy. They calculated its trajectory, accounted for gravitational influences from stars it passed, and worked out where it likely originated. Their conclusion? 3I Atlas probably came from the galactic thick disk. That's a region of the Milky Way where the oldest stars live, stars that formed during what cosmologists call cosmic noon. Cosmic noon was a period roughly 8 to 13 billion years ago when the universe was going through a massive star formation boom. About half of all the stars that exist in the entire universe were born during this era. The galaxy was young, active, and churning out stellar systems at a ridiculous rate. A study from July 2025 estimated with 68% confidence that 3I Atlas is between 7.6 and 14 billion years old. Think about that for a second. Our solar system is 4.6 billion years old. This comet predates our sun by potentially 9 billion years. When this object formed, Earth didn't exist. The sun didn't exist. The planets, the moon, everything we know about our cosmic neighborhood hadn't even started forming yet. One astrochemist put it perfectly when he said 3I Atlas could be one of the oldest objects in the galaxy. We're looking at a time capsule, a frozen relic from an era when the universe was barely half its current age. And here's what makes this age estimate so fascinating. During cosmic noon, the chemical composition of the galaxy was different. There were fewer heavy elements around. Stars back then had lower metallicity, which means planets and comets forming in those systems would have different chemistry than the objects we see in our solar system today. This might explain why 3I Atlas has such bizarre composition. It formed in conditions we can't replicate or fully understand, because those conditions don't exist anymore in our part of the galaxy. Part 2. The Water Mystery. Now, let's talk about water, because this is where 3I Atlas really starts breaking the rules. Standard models of comets tell us that water ice doesn't sublimate much beyond about 2.5 astronomical units from the Sun. An astronomical unit is the distance from Earth to the Sun, so 2.5 AU means about 2.5 times that distance. Once a comet gets farther out than that, it's too cold for water to turn into gas efficiently. The comet should basically go dormant. 3I Atlas didn't get the memo. NASA's Swift Observatory detected hydroxyl emission from 3I Atlas at a distance of 3.51 astronomical units from the Sun. Hydroxyl is what you get when water molecules break apart in sunlight, so detecting hydroxyl means detecting water. The measured production rate was approximately 1.36 times 10 to the 27th molecules per second. In practical terms, that's about 40 kilograms of water every single second. Scientists described it as water being ejected like a fire hose at full blast, at a distance where most comets are barely active. To produce this much water at that distance, the comet would need at least 8 to 9 square kilometers of its surface actively sublimating. That means more than 20% of the entire surface has to be spewing water. For comparison, typical comets in our solar system show active fractions of only a few percent, maybe 2% or 3% of the surface is active at any given time. Why is 3I Atlas so active? One theory is that it has unusually large water ice grains mixed throughout its coma. These ice chunks could be continuously sublimating as they float around the nucleus, creating an extended source of water vapor that keeps the fire hose going even when it shouldn't. But here's where it gets even weirder. Remember how I said this comet is producing tons of water? Well, compared to everything else it's producing, water is actually the minority component. Part 3. The Upside Down Comet. Most comets are basically dirty snowballs. They're primarily water ice with some other volatile compounds mixed in. Carbon dioxide makes up maybe 10 or 20% of the total. Carbon monoxide is even less. Water dominates. 3I Atlas is the exact opposite. Observations from the James Webb Space Telescope in August 2025 revealed the gas composition coming off this comet. Are you ready for this? Approximately 87% carbon dioxide, 9% carbon monoxide, and only 4% water. Let me repeat that because it's genuinely shocking. This comet is 87% carbon dioxide by gas output. Water is just 4%. It's an upside-down comet. Everything is inverted from what we expect. The total mass loss rate was calculated at about 129 kilograms per second of carbon dioxide alone. To give you a reference point, a human produces about 1 kilogram of carbon dioxide per day through normal breathing. This comet is expelling the equivalent of 11 million humans' daily carbon dioxide output every single second. The carbon dioxide to water ratio here is about 21:1. That places 3I Atlas completely outside the range of any known solar system comet. Nothing we've observed in our cosmic backyard has chemistry like this. There's more. The comet has been classified as C2 depleted, meaning it shows extremely low levels of diatomic carbon compared to cyanogen. This is a chemical fingerprint that tells us 3I Atlas has probably been in deep freeze since it formed billions of years ago. It never got warm enough to process or alter its original composition. What we're seeing now is pristine material from an ancient protoplanetary disk that froze solid and stayed that way for most of the universe's history. This carbon dioxide dominance suggests 3I Atlas formed much farther from its parent star than typical comets in our solar system. Way out in the cold outer regions of a planetary disk where carbon dioxide ice is stable, but water ice has already condensed onto bigger objects or gotten locked away. Part 4. The Anti-Tail Phenomenon. You know how comet tails work, right? As a comet approaches the sun, solar radiation and the solar wind push dust and gas away from the nucleus, creating a beautiful tail that always points away from the sun. That's Comets 101. 3I Atlas has a tail that points toward the sun. When the Hubble Space Telescope imaged this comet on July 21, 2025, astronomers spotted something they called an anti-tail. It's a structure of scattered light that extends in the sunward direction instead of away from the sun. The Webb telescope confirmed it in August. So did the Keck 2 telescope. This sunward plume is real. Now, to be fair, anti-tails aren't completely unique. They've been observed in a handful of solar system comets before. But what makes 3I Atlas's version particularly interesting is its persistence and the chemistry associated with it. Spectroscopic data showed that both nickel and cyanide emissions extend in both the solar and anti-solar directions.
The anti-tail appears to be a jet of material shooting toward the Sun, visible in composite images from observatories in the Canary Islands. The leading theory is that dust particles in this plume are being influenced electromagnetically by the Sun's magnetic field in ways we don't fully understand yet. The particles might have unusual charges or compositions that cause them to behave differently than normal comet dust. But here's what's fascinating about this. An anti-tail is a visually striking anomaly that makes 3I Atlas look wrong even to the casual observer. When you see an image of this comet, your brain immediately registers that something is off. Tails aren't supposed to point that way. Part 5. The missing acceleration. Let's talk about physics for a minute. When comets outgas, they're essentially creating thrust. Gas and dust shoot out from the surface, and by Newton's third law, that creates an equal and opposite reaction that pushes the comet. This is called non-gravitational acceleration. The most famous recent example is Oumuamua, the first confirmed interstellar object, which showed unexplained acceleration that sparked all kinds of wild speculation. Even normal solar system comets like 67P, which was studied up close by the Rosetta spacecraft, show measurable changes in trajectory due to outgassing. 3I Atlas is clearly outgassing. We've established that. It's pumping out water, carbon dioxide, carbon monoxide, hydrogen cyanide, dust particles, and metals. All of that material is shooting off into space at high velocity. There should be measurable acceleration. Instead, astronomers found basically nothing. Using positional data from May through September 2025, researchers calculated an upper limit on non-gravitational acceleration of less than 3 × 10 to the -10th astronomical units per day squared. That's an absurdly small number. It's essentially zero, given the level of activity we're observing. This led to a surprising conclusion. The nucleus of 3I Atlas must be way more massive than anyone initially estimated. If the outgassing isn't producing measurable acceleration, it means the object is so heavy that the thrust is negligible. Calculations based on mass loss rates and outflow speeds from the James Webb data suggest the comet must have a mass exceeding 33 billion tons and a diameter of at least 5 kilometers. Hubble put the upper limit at 5.6 kilometers across, though it could potentially be as small as 320 meters if it's made of extraordinarily dense material. Think about what this means. Either 3I Atlas is a genuinely large comet, much bigger than typical periodic comets, or it has an unusually dense rocky or metallic core hidden beneath the ice. Maybe both. Either way, we're looking at an object that's hefty enough to shrug off the rocket effect of continuous outgassing. Part 6. Strange light behavior. Here's another optical weirdness. When light reflects off a comet's dust, it usually shows what scientists call positive polarization at certain angles. This is a property of how light waves oscillate after bouncing off particles. Most comets and asteroids in our solar system produce this expected polarization pattern. 3I Atlas showed extreme negative polarization of -2.7% at low phase angles. That's the opposite of what normally happens, and it's never been seen before in any known comet or asteroid. Negative polarization means the reflected light is behaving in a way that suggests the dust particles have unusual properties. Maybe they're metallic. Maybe they're organic compounds with strange structures. Maybe the particle size distribution is different from regular comets. Whatever the cause, light is interacting with this comet's material in an anomalous way. This isn't just a curiosity. Polarization measurements are one of the tools scientists use to figure out what comets are made of without having to go there physically. The fact that 3I Atlas breaks this diagnostic tool means we can't easily compare it to other objects. It's in its own category.
Part 7. Statistical Coincidences. Now we get into territory that's a little uncomfortable for some scientists, but fascinating for everyone else. The trajectory of 3I Atlas through our solar system has some statistically unusual features. Its orbital plane is tilted at 175 degrees, which means it's moving retrograde, basically backward compared to the planets. But here's the thing, it's only tilted about 5 degrees from the ecliptic plane, which is the flat disk where all the planets orbit. This near alignment with the solar system's plane happens in only about 0.2% of random trajectories coming from interstellar space. On top of that, 3I Atlas made unusually close passes to multiple planets. It came within 0.19 AU of Mars on October 3, 2025. Then 0.65 AU from Venus on November 3rd. Later, it passed within 0.36 AU of Jupiter on March 16, 2026. Harvard astronomer Avi Loeb calculated the combined probability of all these close encounters happening by chance at less than 0.05%. That's 1 in 20,000. And here's one more strange coincidence. The inbound direction of 3I Atlas lies within 9 degrees of the famous WOW signal. That's the mysterious radio transmission detected in 1977 that has never been explained. The signal came from the direction of the constellation Sagittarius, and so did 3I Atlas. The odds of this alignment occurring randomly are around 0.6%. Now, low probability events happen all the time in a universe with trillions of objects flying around. Somebody wins the lottery even though the odds are astronomical. But when you stack up several low probability events together, it starts feeling less like coincidence and more like pattern. Does this mean anything? Probably not, but it's the kind of thing that makes you pause and think. Part 8. The Dark Forest Hypothesis. I need to address the elephant in the room. There has been speculation, primarily from Harvard astronomer Avi Loeb and colleagues, about whether 3I Atlas could potentially be artificial, as in alien technology. Let me be absolutely clear up front. The overwhelming scientific consensus is that this is a natural comet. NASA, the European Space Agency, and virtually every credible institution has stated that all the data supports a natural explanation. But the hypothesis exists, and it's worth understanding why some people have entertained it, even as a thought exercise. Loeb's paper, which he explicitly framed as largely a pedagogical exercise, explored the possibility under the framework of the dark forest hypothesis. This is a concept from Chinese science fiction author Cixin Liu's novel The Dark Forest. The idea is that the universe might be filled with intelligent civilizations that stay silent and hidden because revealing yourself is dangerous. Any civilization that makes itself known risks being attacked by others seeking to eliminate potential future threats. Under this framework, Loeb noted that 3I Atlas's perihelion, the closest point to the Sun, occurred on October 29, 2025, when the comet was on the opposite side of the Sun from Earth. From our perspective, it was hidden behind the Sun.
If you were an interstellar spacecraft wanting to enter our solar system covertly, this would be the ideal moment to perform what's called a reverse solar Oberth maneuver. That's a high-thrust braking technique that uses the sun's gravity to slow down and become gravitationally captured by the solar system. Loeb assigned 3I Atlas a 6 on his proposed scale, where 0 is definitely natural and 10 is definitely technological. That corresponds to what he estimated as a 30 to 60% chance of being artificial. His reasoning was based on the accumulated anomalies, the trajectory coincidences, the lack of non-gravitational acceleration despite outgassing, the unusual chemistry, the extreme polarization, and the statistical improbability of such a large interstellar object given what we know about mass production in planetary systems. But here's the thing, the scientific community largely rejects this hypothesis. NASA's Tom Statler stated categorically that all available data indicate 3I Atlas behaves like a comet and shows patterns consistent with other known comets even if some features are unusual. There's no sign of alien technology. Astronomer Jason Wright at Penn State has been particularly critical, pointing out that many of the cited anomalies either aren't actually anomalous, have changed as more data came in, or are being selectively interpreted. Anti-tails, for example, aren't unique to 3I Atlas. The unusual polarization could result from dust composition rather than artificial origins. The SET Institute published a direct response emphasizing that 3I Atlas exhibits clear cometary activity with a resolved coma, outgassing of multiple volatile species, and a trajectory entirely consistent with natural ejection from another stellar system billions of years ago. So why bring this up at all? Because it illustrates something important about 3I Atlas. This object is weird enough that it pushed some scientists, even briefly, to consider extraordinary explanations. That's how far outside the normal range of comet behavior it falls. The fact that serious researchers even entertained the artificial hypothesis, however skeptically, tells you just how puzzling this visitor is. For the record, I'm firmly in the "it's a comet" camp. But it's a comet that's challenging our models and forcing us to expand our understanding of what's possible in nature. Part 9. Observations from Mars. One of the coolest aspects of the 3I Atlas encounter is that we got to observe it from multiple vantage points, including Mars. Because the comet reached its closest point to the Sun when it was on the opposite side from Earth, ground-based telescopes couldn't see it during peak activity. But spacecraft orbiting Mars had a perfect view. The European Space Agency's ExoMars Trace Gas Orbiter used its camera system to image the comet during its closest approach to Mars on October 3, 2025. This was a technically challenging observation because 3I Atlas was somewhere between 10,000 and 100,000 times fainter than the usual targets this camera looks at. But they managed it with 5-second exposures, capturing images of the nucleus and surrounding coma from about 30 million kilometers away. NASA's Mars Reconnaissance Orbiter also targeted the comet with its HiRISE camera. HiRISE is a half-meter telescope, and if the observations were successful, they would provide resolution nearly 3 times better than Hubble. That would be the clearest view anyone has ever gotten of this interstellar visitor. China's Tianwen-1 Mars orbiter also redirected its instruments toward 3I Atlas. So we had multiple spacecraft from different countries all coordinating to catch this once-in-a-lifetime opportunity.
The data from these observations is still being analyzed, but early results show a clearly active comet with an extended coma and complex structure. Every new image adds details to our understanding of what this object looks like and how it's behaving as it passes through the inner solar system. Part 10. The ION Campaign. In October 2025, news outlets reported that the International Asteroid Warning Network, or ION, had activated a monitoring campaign focused on 3I Atlas. This led to some sensational headlines suggesting that planetary defense systems were being deployed against a potential threat. Let me set the record straight. ION announced a comet astrometry campaign running from late November 2025 through January 2026. The purpose was explicitly stated: to improve techniques for accurately measuring comet positions. This is a training exercise, not an emergency response. Comets present unique challenges for precise measurement because they're fuzzy. They have extended comas and tails that can throw off the measurements of where the nucleus actually is. If you're trying to calculate an orbit precisely, you need to know the exact position of the solid nucleus, not the center of the gas cloud around it. ION used 3I Atlas as a convenient target to practice these measurement techniques. The campaign included a workshop on proper comet astrometry methods. Observatories around the world participated to develop better protocols for future comet tracking. This represents the first time ION systematically targeted an interstellar object in a coordinated observational campaign, which makes it scientifically significant. But it's emphatically not an indication of danger. 3I Atlas poses zero impact risk to Earth, and this campaign was about refining methodology, not planetary defense. The safety answer and what it all means. So let me answer the question from the title directly and unambiguously. Is Earth in danger from 3I Atlas? No, absolutely not. Zero danger. NASA, the European Space Agency, and every credible astronomical institution worldwide have confirmed that the comet's trajectory keeps it at a safe distance at all times. The closest approach to Earth occurred on December 19, 2025, at approximately 1.8 astronomical units. That's roughly 270 million kilometers or 167 million miles away. To put that in perspective, that's nearly twice the distance between Earth and the Sun. The object reached its closest point to the Sun on October 29th at 1.36 astronomical units, which places it between the orbits of Earth and Mars. It never came anywhere near our planet. There is zero possibility of impact. The orbit calculations are rock solid, and they show an object passing through and then leaving forever. But here's what's genuinely profound about 3I Atlas. While it poses no physical threat, it represents something far more significant. This is a messenger from an era of the universe we can barely comprehend. It's a frozen sample of materials and conditions from cosmic noon, a time when the galaxy was young and star formation was at its peak. Think about what we've learned. This object is potentially 14 billion years old. It predates our solar system by billions of years. It formed in a stellar system with different chemistry than ours, in conditions that no longer exist in our part of the galaxy. It's been wandering interstellar space, accumulating velocity from countless gravitational encounters, carrying its ancient composition unchanged through the darkness. And now, for a brief moment in cosmic time, it's passing through our neighborhood. We get a few months to study it before it disappears back into the void, never to return. The chemistry alone is revolutionary. The carbon dioxide dominance, the sequential metal emissions, the unexpected water production at extreme distances, the inverted composition compared to everything we know. Each of these features tells us that planetary systems in the early universe produced objects fundamentally different from what we see locally. The physical properties are equally striking. The massive nucleus that shrugs off outgassing thrust, the extreme negative polarization suggesting exotic dust, the anti-tail pointing toward the sun, the near alignment with our solar system's plane despite coming from interstellar space. Every measurement we take expands our understanding of what's possible. Every observation challenges our models. This is science at its best, where nature presents us with something unexpected and forces us to think bigger.
3I Atlas is teaching us that the diversity of objects in our galaxy is far greater than we can infer from our solar system alone. We've only seen 3 confirmed interstellar visitors: Oumuamua, Borisov, and now Atlas. Each one has been radically different from the others and from anything in our cosmic backyard. Oumuamua was bizarre and cigar-shaped with unexplained acceleration. Borisov looked more like a conventional comet, but still had distinctive features. And Atlas falls somewhere in between, clearly cometary, with extensive outgassing, yet exhibiting chemical and physical properties that push every boundary. The true significance of 3I Atlas isn't about danger, it's about wonder. It's about recognizing that we live in a universe filled with ancient travelers carrying stories from places and times we can barely imagine. As this comet continues its journey away from us, accelerating as the sun's gravity releases its hold, we're left with data, with questions, and with expanded horizons. The James Webb Space Telescope will continue observations as long as possible. Ground-based observatories will track it until it fades from view. And somewhere in all that data are answers to questions we haven't even thought to ask yet. There's a poetic sadness to this encounter. We're witnessing something that has been alone in the dark for billions of years, something that predates everything familiar to us. And we get just this brief window to say hello before it's gone forever. No human will ever see 3I Atlas again. This was our one chance. But what a chance it was! We've learned that comets can produce industrial chemistry naturally, that objects from the early universe have compositions we never predicted, that even after decades of studying comets, nature still has surprises for us, that the galaxy is stranger and more magnificent than we often appreciate. The danger of 3I Atlas was never to our planet. The danger is to our assumptions, to our comfortable models of how the universe works, to the notion that we understand comets because we've studied the ones nearby. Every interstellar visitor forces us to acknowledge that our solar system is just one tiny example in a vast cosmic collection, and there are wonders out there we haven't even begun to catalog. So no, Earth is not in danger, but our understanding of the cosmos has been beautifully disrupted by an ancient wanderer passing through, reminding us that the universe is far older, far stranger, and far more amazing than we give it credit for. And that's the real story of 3I Atlas. Subscribe if you want more cosmic mysteries like this one.